Hi, welcome. I'm Sir Jan. In this video, I will discuss to you about a special type of variation that is the direct variation. Before that, let's go back to our example about papers. Do you know that an increased demand of paper contribute to the increased numbers of trees being cut? I know that you will agree on this. If paper were recycled regularly, then global warming and other harmful effects of waste can be prevented or decreased, and thus we will have a greener and healthy planet. Paper recycling does not only save the earth, but it could also contribute to a healthy economy and to increase the income of many individuals. This is just one situation where we can think of a question such as, will a decrease in production of papers contribute to the numbers of trees being cut? I know for sure you have your own reflection on this matter. This type of question can be answered using the concept of variation. As what I've told you before, there are several relationships of quantities that you will encounter in this situation. You will learn how a change in one quantity have a predictable change in the other. These are the objectives of our lesson. Number 1, illustrate situations that involve direct variation. Number 2, translate into variation statement, a relationship involving direct variation. Number 3, solve problems involving direct variation. I know that you are now very excited to learn. Let's analyze and answer some activities. Helen and Joanna walk a distance of 1 kilometer in going to the school where they teach. At a constant rate, it takes them 20 minutes to reach school in time for the first class. One particular morning, the two became so engrossed in discussing an incident inside the school during the previous day. Have you heard what happened yesterday? Yeah, that was so embarrassing. That they didn't notice the pace at which they were walking slowed down. Can you please check the time? OMG, it is 2 minutes before the time. What shall we do? And now they are in a hurry, afraid of not being late. What solution should they take in order they will arrive on time? Let's answer some questions. First question. How will they be able to catch up for the lost number of minutes? We can cite 2 possible solutions here. First, they can run or walk faster. Second, they can ride a vehicle. Second question. How are quantities like rate, time, and distance considered in traveling? Looking back about Helen and Joanna, if the rate or the pace at which they were walking increases, then the distance they will cover will also increase. Moreover, if the time at which they were walking increases, the distance also increases. However, if they slow down or the rate decreases, then the time at which they were walking increases. Let's have the second example. A public school launches a recycling campaign of waste materials in order to raise students' awareness of environmental protection and the effects of climate change. Every kilogram of waste materials earns points that can be exchanged for school supplies and grocery items. Paper, which is the number 1 waste collected, earns 5 points for every kilo. The table below shows the points earned by the students for every number of kilograms of waste paper collected. 1 kilogram of papers is equivalent to 5 points. 2 kilograms is 10 points. 3 kilograms is 15 points, 4 kilograms is 20 points, and 5 kilograms is 25 points, and so on and so forth. Question number 1. What happens to the number of points when the number of kilograms of paper is doubled or tripled? For example, when 2 kilograms, which is equivalent to 10 points, doubled, then it becomes 4 kilograms, which has an equivalent points of 20 points. From 10 points to 20 points, therefore the point is double if the number of kilograms is also double. Furthermore, the points is also tripled with the number of kilograms tripled. Number 2 question. How many kilograms of paper will the grade 8 class have to gather in order to raise 500 points? Write a mathematical statement that will relate the two quantities involved. In the previous table, 1 kilogram is equivalent to 5 points. To know how many kilogram in 500 points, we can solve this using the formula points P equals kilogram N times 5. Solving for the kilogram, we just divide 500 by the constant ratio of 5. So, kilogram is equal to 500 divided by 5 will give us 100 kilogram for 500 points. The mathematical statement between points and kilogram is P equals 5N, where 5 is the constant ratio. Next question. In what way are you able to help clean the environment by collecting these waste papers? By collecting waste papers, we can decrease the global warming and save the planet we live in. What items can be made out of these papers? There are many products can be made out of these papers, and some of these are paper bags used in grocery and malls. Whenever a situation produces pairs of numbers in which the ratio is constant, it is called the direct variation. Direct variation can be stated verbally in 3 different ways. Y varies directly as X. Y is directly proportional to X. Y is proportional to X. And translated in mathematical equation as Y equals Kx, where K is the constant of variation. In direct variation, Y equals Kx. If one quantity increases, then the other quantity is also increases. Moreover, if one quantity decreases, then the other quantity also decreases. Given the table of time and distance, this can be stated as distance varies directly as time, or D equals KT. To solve for K, divide the distance by time, then it will give us 10. Then replace K by 10, so the mathematical equation of this table is D equals 10T. Let's graph this using a Cartesian coordinate plane. After plotting, we can observe that the graph is a straight line. As x increases, y is also increases. Let's have another example. Write the mathematical statement. The fare F of a passenger varies directly as the distance d of his destination. So the answer is F equals KD. The cost C of fish varies directly as its weight in kilograms. So the mathematical statement is C equals KW. Given the table of X and Y, it can be stated as Y equals KX. To solve for K, we just divide Y by X, and it will give us Y equals negative 3x. In this graph, the constant of variation k is 7. Therefore, the mathematical statement is y equals 7x.